Alright, in this video we're going to talk about another type of improper integral. And this one, these can be a little deceiving because there's no bells and whistles. You don't see the negative infinity or the positive infinity in the limits of integration, which usually gives it away that you're dealing with an improper integral. Usually at the beginning of a calculus course you don't run into any of them, and then they magically kind of throw them in at you, and then from there on you have to be careful and ask yourself, is this in fact an improper integral? And the thing to notice really is, are you integrating over a discontinuity? And if you think about the graph of 1 over x squared, well, in terms of the domain, if you plug 0 into this, you're going to be dividing by 0, which is bad. So there is an infinite discontinuity in this problem. And if you think about the graph of 1 over x squared, it looks like this. So what we're trying to do is integrate from 1 to 0. So we're trying to calculate the area to the left of the y-axis. And again, you can see it's spiking off to infinity here. The idea is pretty much the same as in the other examples. What we're going to do is we're still going to turn it into a limit problem. Let's see if I can find my pen here. And what we're going to do is, instead of integrating from negative 1 to 0, we'll go from negative 1 to some other value. We'll call it again t. And what we're going to do is we're going to let t move over to the right. So in this case we're integrating from negative 1 to 0. Let's make it negative 1 to t. And in this case t needs to be approaching 0, but from the left side. So wherever the discontinuity is, that's where you're going to plug in t, just like in the other examples, wherever the infinity was, that's where you plugged in the t. And again, you basically just turn it into a limit problem along with a definite integral. So x to the 1 over x squared is the same as x to the negative second. So if I calculate the antiderivative, I'll get the limit. Again, t is approaching 0 from the left. The antiderivative of x to the negative second is negative 1 over x. From negative 1 to t, I plug in my limits of integration. I'll get negative 1 over t minus negative 1 over negative 1. And this simplifies down to the limit as t approaches 0 from the left. We're going to get negative 1 over t. The two negatives will make a positive, so I have minus 1. But the problem in this case, if t approaches 0 from the left, so in this part I'm plugging in very small negative numbers. And think about like 1 over 0.1, 1 over 0.01, 1 over 0.001. Those numbers are going to get bigger and bigger and bigger. Well, okay, well I'm not using those, but I've got a negative. And since it's approaching 0 from the left, I'm using small negative numbers, which are going to cancel out with the negative that's already there. And that'll give me infinity minus 1, or infinity is my answer. So notice we did a pretty similar example. In another video we looked at 1 over x squared from 1 to infinity, and we got a finite number. In this case we're doing from negative 1 to 0, and it turns out somehow this area just to the left of the y-axis is just a bit too big, and when we integrate it we get infinity out. So again, this is the basic trick you have to look for on these problems. You have to think, where are there infinite discontinuities? And that's where you're going to end up plugging in your t's and evaluating your limits. So we'll do another example in another video where, just like when you have the negative infinity to positive infinity, you have to break it up into two separate integrals. If your infinite discontinuity should happen to occur in the middle of your interval, instead of just having one integral that you have to evaluate, you'll end up having two. So take a look for another one of those videos. It should be pretty close by to the link that you selected for this one.